In this lesson, you'll be learning about the different classifications of triangles, or maybe relearning them. Something that's taught in the middle school, maybe even elementary school. That you can define a triangle by its angles and the type of angles that it has. There are acute triangles, obtuse triangles, and right triangles. We also can classify triangles by what kind of sides they have. A scaling triangle has no sides equal. An isosceles triangle has two sides equal and also two angles that are equal. An equilateral triangle has all sides equal and all angles equal. The triangle we're going to focus in on the most is one of the more important triangles, the isosceles triangle today. So in an isosceles triangle, it'll have two sides that are equal and two angles that are equal. In this lesson, we want you to try to solve these questions yourself first. Read the question, get as far as you can, and then while you're doing this, the video is paused, and then you can unpause the video when you're ready to get a hint or to see the final solution. So why don't you try question number 1, reading it over, and do the best you can to set up an equation to find the perimeter of the isosceles triangle pictured. And then unpause the video when you're ready to continue. So did you get this far? Were you able to determine that it has two sides that are equal and that those sides are the legs? The legs are equaling to each other, giving us x equals 4. And that's a very good start here. Did you finish up the question by actually finding the perimeter? So at the very end, remember to find your x and then plug it into the different sides of the triangle to find each length of each side. So if x is 4, 2 times 4 is 8, minus 5 is 3. 3 times 4 is 12, minus 9 is also 3. That's good news because our two sides came out to be exactly the same. The triangle was supposed to be isosceles, so that's a good sign. Plugging in 4 in for x here, 4 minus 2 is 2. So the total perimeter would be 3 plus 3 plus 2. Perimeter would be worth 8. All right, next question up. Read the question, pause the video, and try to answer the question, this multiple choice question, and unpause when you're ready. Remember, it's always a good idea to take those measurements and put them into the angles in the picture. All right, looking at a good start to the question. In colored markers, red, blue, and green, I put the given information, and I found out this other information in black. I didn't finish the question. We're going to finish it right now. So how did I do this? So I put down the colored given angle measurements in the picture, and then I realized that I had two angles of the three angles of this triangle. So I have 100 and I have 30. That's altogether 130. So I figured out that angle C would have to be 50. The next angle that I found was the angle that's adjacent to this 100-degree angle. These two angles are forming a semicircle, or they're forming a straight line worth 180 degrees. These two angles are linear angles. This angle would have to be worth 80. And then I looked at this triangle and determined that if I had 50 that was given and the 80 that I just found, so far I've got 120 degrees, or 130 degrees. So that this last angle here would have to be 50 so that they add up to 180 in total. Then I can go through the different choices and see which one has to be true. Is ABD obtuse? ABD is not obtuse because it has no obtuse angles. All the angles are less than 90 degrees. Is triangle ABC isosceles? So let me find ABC. ABC is this triangle here. And I don't have any measurements of the lengths, but in an isosceles triangle, two of the angles are equal. So I've got a 50-degree angle here and a 50-degree angle here. So that must mean that this is the correct answer. I'll still look over the other answers just to make sure that I'm 100% sure that I'm right. And is ABD, the measure of ABD, 80? ABD is not 80, it's 50. ABC would have been 80, so it's not correct. And is triangle ABD scalene? ABD has no measurements of sides given, but it has two angles that are equal. Sometimes even turning the picture this way can help you see different triangles for what they are. So in this triangle ABD, it is not scalene. A scalene triangle has all three angles different and all three sides different. Here we've got two sides that are, or two angles that are equal. So these two sides would be our legs, and these two sides would be equal. That would be a isosceles triangle, not scalene. All right, the next question here, we're going to pump it up with the rock. So question number 3, when the question says to explain, and this is a big part of mathematics, explaining your thinking. When the question says to explain, officially to New York State, they say the explanation must include at least one complete sentence. And you want to flex your geometry vocabulary. You don't want to just talk in general terms and make up your own words for things. Like, don't use the word, don't use the word vertical if the angles are vertical. Don't just say that the angles are across from each other. Try to use as much correct vocabulary as you can. So looking at this question here, why don't you pause the video when you finished reading it and unpause when you're ready to see an explanation of it. I can tell right away that I'm dealing with a triangle that's going to be isosceles. If GH is equal to HI, there'll be an isosceles triangle here that will help me figure out some of the missing angles. Be sure to read all the information below as well. They wouldn't be giving you the information if it wasn't going to be used. Just unpause the video when you're ready to see a hint. All right, well, here's a really big step towards getting the correct answer. Again, I put the colored information in from the givens, and they're asking me to explain why these two lines or segments are parallel to each other. Well, let's take a step back and see what I've done. First of all, I put down the information that was given, and once again I used linear angles to figure out that this angle here at HIG, that angle would have to be worth 65 degrees. So once again, the reason why that angle's 65 degrees is because linear angles add to 180 degrees. That's part of my explanation. And it's going to take me more than just one sentence to say all this because there's a lot of things happening in the picture. The next thing I noticed is that these two sides were the same length. So I even pictured this in my head being twisted or rotated this way. If these two sides are the same length, then that means that these two angles are the same measurement. So knowing that this is 65 can help me find this angle as being 65. Those are called the base angles of an isosceles triangle. So the reason why angle HGI is 65 degrees is because an isosceles triangle, I'll just abbreviate, isosceles triangle has equal base angles. And then I found angle 50, the 50-degree angle right there. And I used the fact that I had two angles of a triangle, 65 and 65, so that third angle would have to be 50. So the reason why that angle is 50 degrees is because a triangle has 180 degrees. And then finally, I'm able to say that these blue segments here are parallel to each other because of the matching 50-degree angles. So we've got parallel segments because the corresponding angles are equal. Now, a very good explanation includes all of this information. At this stage in the game, in terms of what you've learned, if you've used some of the vocabulary to explain what was happening in this picture, that's a good step in terms of getting better and better in terms of communicating what you know about geometry. And remember, this is our first day working with the isosceles triangle here at the high school, or at least when this video was made, so cut yourself some slack if you're not connecting the dots perfectly right now. Let's see how the next one goes. Yeah, question number 4. So a reminder, if you're unfamiliar with the word in any class, math class, social studies, science, if you're on English class especially, I would imagine, if you're unfamiliar with the word, just Google search it or ask Alexa. And if you can't get an answer that way, then just take an educated guess of what it could mean. So either look this up, or maybe you even know what the word means, or take a good guess of what the word median means in the picture below. So what do you think medians do to segments? It says that DB is a median to AC. Use that guess or use that Google search to come up with the answer to this question here, finding the measurement of BDC when we know that the measurement of angle DAB is 32 degrees. Unpause the video when you're ready to see the solution. All right, so median sounds like medium. So it would be a good guess to say that it's halfway. If you did a Google search, like I did here, I looked up median definition, geometry, and it's telling me that in geometry, a median is a line segment that joins a vertex to the midpoint of the opposite side. And you're showing me some examples on an image search too. So let's take a look at my answer, that the answer is 58 degrees. It did not ask to explain, to get credit, but I'll give you a quick explanation of what I did. First of all, it says that DB is a median. That must mean that B is a midpoint. Midpoints make two equal segments. Midpoints are halfway across. So I know that this segment is the same as this segment. Do you see how I marked it down with these two little decorations, these little slash marks? That's showing me that these are a matched pair, that this is the same as this. Now they also told me in the reading that AB was the same as DB. So AB is the same as DB. So I've also included the same matching marks here and here. Now I can take a look at these triangles a little bit more closely. The triangle on the left has two sides that are equal, so it's an isosceles triangle. The triangle on the right also has two sides that are equal. All three segments, BC, BA, and BD, are all the same. So where did I begin? Well, I started with the 32 degrees here in corner A, angle A. And if this is an isosceles triangle, that must mean that the base angles are equal. Sometimes it's helpful, like you've seen already, if you rotate the picture, you can actually, make it look more traditional in terms of the isosceles triangle. That is our base. Our vertex is on the top angle. And these angles here are our base angles. The base angles are always equal in an isosceles triangle. So knowing that this was 32 told me that this was 32. And then in a triangle, the three angles have to add up to 180 degrees. So that's what I did next. 180 degrees, take away 32, take away another 32, gave me 116 for the angle ABD. I used linear angles to find out that this was 64. Together these make 180 degrees. And then I may have actually turned my paper sideways to take a look at it. If this angle at the vertex there is 64 degrees, and it's got to be 180 degrees altogether. So far I've got 64 out of the 180 degrees. So I'll take 180, remove 64, and then split the difference to find each of those angles that are left. So that's what my arithmetic has right here. 180 degrees, take away 64 is 116, and 116 split in half is 58 degrees apiece. All right, a couple more questions to practice, and again, this is an opening activity in terms of understanding this. If you're getting some of the answers or part of the answers, that's fine. The fact that this is on a video also means you can also replay it if I'm going too fast, or if you're studying for a test and you want to go back and recapture what we've done today. For question number 5, just like in question number 3, you've got parallel lines. Just remember, you get all these extra goodies when it comes to parallel lines. The corresponding angles being equal, the alternate interior angles being equal. So use all this information that's given in this question to do your best in answering what is the measure of angle ABC. Unpause the video when you're ready to check your solution. But really, give it your best. Did you give it your best effort? At least give it an attempt. Instead of just waiting to see the answer, give it a shot. See how far you can actually take it. It's multiple choice, so dig in and do your very best. Okay, you should be ready to see the solution by now. All right, here's a partial solution. Once again, I wrote down the given information in colored ink, red and green, and in black you can see the steps that I took to start getting closer to the answer. So they're telling me that these lines are parallel. I marked those down with these little arrowheads. Knowing that that's 48 degrees tells me that this angle is 48 degrees because of alternate interior angles being the same. Next up is I took the 48 degrees and the 18 degrees and realized that in a triangle, 3 angles have to add up to be 180 degrees. So 180 take away 48, take away 18, leaves me with 114 for angle HBC. And that's good news because I'm just one small step away from figuring out the answer. I'm looking for the blue angle. The angle in black, 114, helps me figure the blue because these together form a semicircle or form a straight line of 180 degrees. Even drawing in those semicircles is a good idea. Always be on the lookout for linear angles. That's how I determined the answer was 66 degrees. Looking at the choices that are there, I can have even more confidence that I'm correct. It's probably not 18 degrees. 18 degrees is a pretty slender angle. And it's also probably not 114 degrees. 114 degrees would be more than 90 degrees. And just by looks alone, that angle in blue looks to be closed up more than 90 degrees. Even looking at the two choices that are left, if you had to guess, 48 just doesn't seem right if you compare this angle here in red with the angle in blue. Blue seems to be opened up a little bit more. So there's 2 ways to actually hunt down this answer. One by using these steps, and the other one is by checking the solutions over. One more question left to try. We're closing things off here with another famous shape called a parallelogram. Parallelogram is beautifully named because it has 2 pairs of opposite sides that are parallel. So in this picture it says it's a parallelogram, so we know that those 2 sides are going in the same direction. And we also know that these 2 sides are going into the same direction. So you're going to have to play around with some of the vocabulary from previous lessons, including alternate interior angles and the consecutive interior angles, also known as same-sided interior angles. Oh, it's even written right here as a reminder for you. So give this one a try, putting in all the information into the picture We also know that CE is congruent to BE. So it looks like that triangle right there is an isosceles triangle, and that's going to help us find some more of these angles out. All right, so once you've unpaused the video, you can see that I've creeped through the question to find an answer of 44 degrees. And here's a recap of how it was done. We've got the colored in blue, the only information they told us of an angle was at 112 in this parallelogram. So how did I get from this 112 here in D all the way over to angle E? Well, this is how I approached it. I saw that there were two parallel lines going across horizontally in DC and AB. And I thought of this picture as this more traditional way to show parallel lines. There I have two consecutive interior angles that have to be different sizes. This is an obtuse angle, so this would have to be acute. They are not equal to each other when they're on the same side of the transversal, but they do add up to 180 degrees. They are supplementary. So angle A would have to be 68. Then this is one way to get the answer. I took that angle in red here at 68 degrees, knew that these lines would be parallel to each other, and found this angle here to also be 68. Those are your corresponding angles. Then twisting the picture, realizing that I'm in an isosceles triangle. If these two sides are equal to each other, then I know that these two angles have to be equal to each other, and that's how I located this angle up here at BCE at 68. Finally, I just have one last little arithmetic step to do, and that's to say that the triangle is worth 180 degrees. Subtract 68 and subtract 68 again brings me to an answer of 44 degrees. And looking at the choices, it's nice to see it's there. You can see that the 112 is a possibility for the choices, but looking at that angle there, it's definitely closed up way more than 90 degrees. And even by instincts alone, it couldn't be 68 degrees because a triangle has to have 180 degrees altogether, but also if this angle here is 68 degrees, this looks like it's closed up even more, so it's probably not choice 3. So if you were guessing, you might be able to get it down to one of these two choices just by looks alone. It's not a good idea to always go by looks, but it does give you some confidence that you're doing something correctly, and sometimes it's a last resort if you can't quite figure out how to solve the questions and their multiple choice. Well, I do hope that this lesson was fine. It might have been a little bit too quick, and if it was too quick for you, you do have the time to watch it again. And we're definitely expecting you to dig in. And even if you had this lesson delivered to you in the classroom, it's good to see an instant replay on it. People do that all the time with sports. You actually watch a sporting event, then watch the replay again to check out the highlights. This would be an excellent idea. If you're not getting it the first time, take the time to spend it again. And even if you have to try the questions again just before the test, download another example or another worksheet from Schoology, or just watch the video and actually try to rework the questions out. Maybe watch this is maybe just before a big test, which is right around the corner. Digging in again and preparing is always good. You can never be too prepared. So after all that, you guys have a very nice day, and this is Mr. I signing off. Have a nice day.